Our goal is to figure out what the area of a parallelogram is. Now to start out, we're just going to draw a parallelogram. Now to find the area of this parallelogram, what we're going to start out by doing is we're going to divide the area of this parallelogram into other individual areas. So what I've done is I've made two right triangles, and these right triangles are actually congruent to each other, and you can go ahead and verify that yourself. And we've also made a rectangle right here. So I'm going to call each of these areas Area 1, Area 2, and Area 3. Now, if we wanted to find the area of this entire parallelogram, all that we would have to do is we would just have to add Area 1, Area 2, and Area 3 together. Now, here's the thing. We know that Area 1 and Area 3 are equal to each other because remember, congruent triangles have equal areas. So as a result, we can just replace Area 3 with Area 1. And when we add A1 and A1 together, we get 2A1. So, now that we have this, all we have to do now is we just have to figure out what A1 and A2 are. Now, here's the thing. I'm just gonna label this point E and point F, right, before we do anything. So, what I'm going to do is I'm just going to figure out what A1 and A2 are. Now, we know that area 1 is the area of a right triangle, which is going to be 1/2 base times height. Now, the base is AE, the height is BE. So we have 1/2 AE times BE, right? So 1/2 base times height of this right triangle. And then all we have to add now is area 2. And area 2 is just the rectangle. Now remember, rectangle, just base times height. So base times height. So ED times FD. Right? So this is what we have. Now notice how we have 2 times 1/2. That's just going to be 1. So as a result, we just have AE times BE. Now here's the important thing to notice. We know that BE and FD are equal to each other, right? They're equal because they both represent the height of the parallelogram. So we're going to replace BE and FD with height. So BE is height, FD is height. So we're just replacing those with that. And what we know now is we can just factor out h. And when we factor out h, we get AE plus ED. So notice how we have AE plus ED. AE plus ED just represents the base of the parallelogram. So this length right here represents base. I'm just going to erase this. We already know that A1 equals A3. So AE plus ED represents the base of the parallelogram. So I'm just going to represent AE plus ED with just the base of the parallelogram, and we get base times height. So the area of a parallelogram is just like what it is for a rectangle. It's just base times height. Or you can think of the parallelogram as just a rectangle where it's kind of bent, like tilted slightly, right? That's basically what that is. The area of a parallelogram is the same as that of a rectangle. Area of a parallelogram is just base times height.